Ricardo Romero from Tekniker. Thank you for the introduction. I work for Tekniker, that is one of the partners participating in the DIGICHECKS project. Good afternoon, everybody. I wish to thank the organization of the event for letting us to show the work done in this DIGICHECKS project. Okay. The DIGICHECKS project is digital environment for management of permits and compliance in building and construction. It is one of the three sister projects that have been working in digital building permits during the last 3 years, but you are going to see some presentations for the ones you are seeing there, Accord and Check, so I'm not going to go into details about it. I'm going to go to DIGICHECKS. Here you can see some general data. The project duration has been 36 months, and the project, you can see there the project dates. It's going to finish by the end of this month, so we are now with the final conclusions, final deliverables, and so on. These are the participants, 13 entities from 5 European countries. All of them are international firms in the fields of construction, research, and standardization, digitalization, and technology. And here the objective is which is the creation and demonstration of a new digital framework that enables interoperability and communication between different platforms to facilitate the management of construction permits, including compliance verification. Well, some of the fundamentals of this system is, of course, if we are talking about interoperability, the system must make use of ontologies that are the common language that allow the system to interoperate among them. Some other fundamentals is that we must allow the participant and the authorities to define their own processes so that they can adapt the processes and also define their own permit construction rules that can be implemented in the compliance checks. All of this must be an integrated solution and must be based in our understanding in international initiatives and standards. And of course, if we are in an interoperable and distributed system, we must talk about data sovereignty, or what is the same, data spaces. So after the first phase of analysis and requirements definition, we ended up with the system architecture that you are seeing here. We have a core, it is a distributed architecture, and we have a core central services that are mainly, well, we have some user management, some user interfaces, and so on, services related to ontologies and data spaces, but at the very core of the system is the business process modeling engine. That is the service that is going to run the processes you have defined. The processes are defined in business process modeling notation and then loaded into the system and run. At the second level, you can see some other services that are not at the core, but that they are or must be needed in order to run the processes and to solve different steps of the processes. I'm talking about, of course, compliance checking services, but others like VR, artificial intelligence, or whatever you need during the process. And on the left side, you have the data access layer that is in charge of providing access to data from different systems. Like you can have internal systems in the participants, but also external systems like Cadastre or whatever. You can connect to that. Behind this architecture, and also talking about data sovereignty, we have defined the data space system layer that is in the background and is giving support to all the data exchange taking place in every process we have defined here. Sorry. Okay, after the definition of the architecture, we went into the development phase where we build the core services, I said, but in the meantime, we were working in the definition of the pilots because depending on the pilots we wanted to demonstrate, we have to implement that other additional service giving support to that processes. So finally, we defined the pilot projects. You can see here, one of them is from FCC construction. It's about the environmental permits in a part of the highway project in Wales, in United Kingdom. The other pilot and the other process is the power utilities permits, or what is the same, the permit to getting the building connected to the electrical grid. It's in a residential building in Spain. And the third one is from Cree Building, an Austrian company, and it's about building permit, the real building permit, in a commercial building in Austria. So a short summary of the things we did. We had 3 pilot projects in 3 different countries with different project typologies, with 3 different processes that composed of 15 sub-processes, more than 150 total steps, and we did 10 compliance checks. 2 of them were based on rule engine, 4 of them were solved with SQL patterns, and 4 of them were with LLMs. Data exchange, we did the data exchange in the data space from a variety of systems, all of them part of the solutions of the pilot participants. We did connectors to SharePoint, Autodesk Construction Cloud, to Astra and Cadastre Digital Twin by IDP, and different formats, file formats or data formats like PDF, Excel, BIM, GIS, JSON, etc. So other additional services that we included in the system were, for example, some optimization of power consumption for the design lines of the Realia pilot. That was the one about connecting the building to the grid. It was an AI-based optimization service. We had a document viewer that connected to the data space. It's a service that for watching the files, but respecting the data sovereignty of the documents participants are providing to the system. And also we had some virtual reality services that were used for manual inspection, or, for example, in the case of the Austrian pilot, it was used during the public consultation phase, where you have to show how the building will look like to the general public, and this is part of the process there in Austria. Okay, some minor details about the 3 processes. For the FCC, the animal permits for the highway project, it was a process formed by 6 sub-processes, in total 44 steps. Here you see some of them. This is the process defined in BPMN. And these are the compliance checks. Okay, you see the animal. This is the compliance checks we did in this pilot. GCN is that small animal there. And we make compliance checks in order to check the capture method for these small animals, and then another compliance check to validate the density of the density of the traps that were placed to get the capture. More or less the same for the bats. The provision of bat boxes and the number of positions were checked. This is for the Realia process, some figures and some part of the process. I'm just going to show the compliance checks we did, some checking of the documentation provided by the applicant at the beginning of the process, and the most important part in this case is the compliance of the power breakdown distribution. And finally, for the CRE pilot, well, some figures again, and the process, and the compliance checks we did were about project and building description, the area and zoning plan, the floor space layout, and the acoustic report. Some checks around these fields, and okay. So this is more or less what I can tell you in 10 minutes. So I will be here the rest of the day, so you can catch me. Thank you for your attention.